So this is determination of coefficient of discharge of given orifice meter. So in this orifice meter, the aim of the orifice meter is to determine the theoretical discharge through the passage using orifice meter and to find the coefficient of discharge of the given orifice meter. This orifice meter is required apparatus is orifice meter, then differential U-tube manometer, then collecting tank, stopwatch, and then finally scale. This is the orifice meter apparatus diagram. Tabulation of the orifice meter. This tabulation is containing manometer reading H1, H2. So then my difference in H1, H2 value. Finally, head of the orifice meter value. Next one, collecting tank 10 meter rise of water tank duration. Then to calculation value of Q actual discharge value. Finally, the theoretical value of orifice meter. So to calculate from the two values, to calculate the coefficient of discharge of the actual and theoretical value of coefficient of discharge values. This is the orifice meter. From that orifice meter, we conclude the tabulation reading. First one is having two different pipes. One is major diameter, another one is a minor diameter. We are only using for the major diameter pipe. Then, so this is the orifice meter, respective of the major diameter orifice. Then this is the outlet orifice diameter. So this is outlet gate wall. So this is collecting tank. This collecting tank size is to measured by the steel rule, either or otherwise any scale. So how much amount of the volume to containing in your collecting tank. This is to determine yourself. So then, so after switch on the motor, to water is collected in the tank. So in this tank is to fill the water up to the 10 centimeter rise of the water. How much amount of the time to taken to fill the 10 centimeter of the rise of water. So that is calculated by a stopwatch. From that stopwatch to calculate the time. So now we can see how to operate this machine. First of all, switch on the machine. After switch on the machine, the rate indicator is on. So then your single phase motor is running the motor. After running the motor, discharge pipe is to discharge pipe to take the discharge. So this outlet is to confirm your sub pipe. So from that sub pipe, so this you are using only major diameter pipe. This major diameter pipe is open always. So from that major diameter, this is the orifice meter. So this is the inlet of the orifice meter. So this is the outlet of the orifice meter. So this is two inlet and outlet orifice meter connected through the two manometer point. So this is outlet portion. This is inlet portion. From that inlet portion, we have different HG value. So this is potential difference of inlet. This is the potential difference of outlet. So from the two things, H1 and H2 is to mention your tabular column. So from that reading to come out the this is the outlet of the orifice. From the outlet of the orifice, so this is the discharge of the water. So this discharge is water is to collect the collecting tank. In this collecting tank, so already you know about that. So 10 centimeter of the rise of water, how much amount of the time should be taken in your stopwatch, that will be noted in the tabulation. After that, so this is up to the first reading. So the second reading is again we go to the change the gate wall of the outlet discharge. So automatically change the HG value. H1 and H2 value is changed. So this is also noticed in your tabulation. This is the second serial number of the reading. So then you have to similar procedure should be followed in your 10 centimeter of the rise of water. So this is up to 4 to 5 reading you will take in your after getting the reading to follow this formulas. First one, actual discharge of the formula. This is Q actual. So A is the area of the pipe. Then R is the collecting tank area. Then this is divided by time taken. So this is the actual discharge of the collecting tank, water. Next one, theoretical discharge of the Orifice method, that is Q theoretical is equal to K root of H meter cube per second. So these things are to mention in your below the formula. So how to calculate the K A1 and then A2. So everything should be in given, should followed in your this values to calculate the theoretical value and then actual value. After that, to find the coefficient of the discharge. Coefficient of the discharge is Q actual divided by Q theoretical. So this is having both the same unit because you have no units of the CD value. So this is the coefficient of the discharge of the orifice meter.